All right, so let's talk about evaluating a limit. Now, this is not our first time looking at a limit. We understand that for a limit to exist, both the left hand and the right hand limit both need to be approaching the same value. Then the limit exists at a specific value. But let's talk about some ways we can evaluate some limits that they're not creating a table of values or looking at a graph, but really how can I evaluate this limit without doing that? There certainly has to be some kind of algebraic process. Well, first of all, we do have a lot of properties of limits. So you can certainly pause this video and write these down. But notice kind of the consistency here. If we're finding the limit as x approaches some constant, because that's what we're looking at here, not as x goes to infinity or negative infinity or something, but x goes to 0, x goes to 3, something like that. If we could split our equation up or our function up into two different functions, then it would be as simply the limit as x approaches that first one plus the limit as x approaches the second one. It would be the limit as x approaches that constant for the first one plus the limit as x approaches the constant for the second one. Same thing if we're splitting it up by subtraction. If there is some scalar, some constant that is multiplying our function, we can bring it outside the limit. That kind of factors out. If it's multiplying those two, we could break it up as the limit as x approaches c for the first function times the limit as x approaches c for the second one. So this just gives us the ability to break down. So if we look and we see something that looks so complicated that we can break it down and find the limit of these individual pieces, and that can certainly help us. Now, think about how we could break down each of these. This would be the limit as x approaches 4x squared minus the limit as x approaches 4 of 6x plus the limit as x approaches 4 for 3. We can break that down. Here we see this is the same thing as the limit as x approaches 3 for 8 minus x to the 1/2. And we can see back from this right here, we didn't actually talk about that one, but that would be the same thing as the whole limit being raised to that value, or we could keep the square root going. So you could rewrite this as the limit as x approaches 3 of 8 minus x, this whole thing raised to the power of 1/2, or the whole thing taking the square root. And of course we could break this down to be the square root of the limit as x approaches 3 of 8 minus the limit as x approaches 3 of x. So we could break it down to that from the original. And finally over here, we could break this down to be the limit as x approaches -2 of 4x cubed plus the limit as x approaches -2 of 1 over the limit as x approaches -2 of x minus the limit as x approaches -2 of -5. We could take the limit of essentially the top and the bottom, and I can see here that we could bring that 4 out to the front, we could keep the x, and because that's being cubed, we could cube it. So here's how we can break them down to actually evaluate the limit. Sometimes breaking it down is helpful to look at each individual piece, but I'm going to give some suggestions on how we can actually evaluate these limits a little bit easier.